Hi, Sportster Paul with our third impression of HSMWorks. It's a CAM program, Computer Aided Manufacturing. Because it's a Works, it goes inside SolidWorks, a CAD program, Computer Aided Design, and the CAM programs make the G codes and the things to run your milling machine or your lathes or stuff like that. Third impression, I'm delighted. I'm not asking for my money back. This is the program I'm going to use. And I swore I'd never buy subscription software, but the simple economics, I got a deal, $300 the first year, $500 after. Usually it's $500 a year, $60 a month if you just want a month. I could take the $5,000 I would spend for BobCAD or SolidCam or MasterCam or any of these others, put that in the stock market, and it would be 17 years, as you know, if I make 8%, which is average. It'd be 17 years before I'd run out of that money. At my age, I'll probably be dead in 17 years. So it actually makes sense. If it expires, it's not perpetual. So if it expires, I can always say, well, I'll buy 1 month for $60 and go do whatever files I need, and then I can let it expire again if I need to do that. There's things, it's not the perfect program, right? I like Visual Mill for the initial setup where you set the part zero. This one's a little clumsy, although my friend Dave, the machinist who invented this part we're going to go look at, he explained to me that in the Inventor or Fusion things, you can click on that. He calls it a gnomon, the little colored arrows that show XYZ. You can click on it and flip it. And I assume that'll come to SolidWorks one of these days. What else? I didn't need to make a sketch to do the flat last episode. It wasn't like SolidCam, which I prefer because it has this point to point. You can just hit 2 points and it'll connect a line and there's your geometry. But with HSMWorks, I could pick one of the short little lines on that flat and then say extend that toolpath a couple inches and do what I had to do without drawing a sketch. Same thing, the slopes, it worked out perfectly, no sketch needed. Everything about it. And then what I've been practicing on, the holes. And so it does the holes like, you know, the best holes actually was BobCAD because it's kind of feature based. And so you say, I want a tapped hole, and it'll do the center drill, the drill, a chamfer, and a tap. It'll get all those lined up. And then you got to figure out, make sure that the tools are in the right order and stuff like that, but not the end of the world. This one's more manual. There is a wizard, and we'll do the wizard first to show you, why it doesn't make sense and why it fails and why I think, all the automatic stuff. This part I'm going to show you was made to trip up automatic feature recognition. And this feature business is why, in general, I love the holes in BobCAD, but the fact that you're not telling it what the feature is, you're not saying, okay, here's a pocket, there's a geometry. You just highlight the geometry and then it kind of decides whether it's a pocket. And you can change that around, but I'd just rather know what I'm doing going in. And then SolidWorks CAM by CamWorks. They've broken features and operations into two separate trees. I'm always confused. Am I in? Am I out? What belongs to what? What operation is what? It's always trying to update. You change anything and it goes and puts in all kinds of extra operations or features you didn't want. So that and MasterCAD are the last on my list. But SolidCam was the most capable, but this one, for the price, for everything it does, the simulator's almost as good, but not quite. I'm happy enough. So let's get up to SolidWorks. Here we are, the way we left it. Top setup, bottom setup. I still don't know why it's bold, why bottom setup is bolded. Maybe that's because that's where if you went up here and said next operation. But I'd rather go down here and say new operation. 2D milling, is it here? New operation. Oh, okay, duh. Drilling. Drill wizard. And I'm sorry, I'm not big. See, it's looked at the solid model, said, oh, I found the holes. And the problem with all these programs is these holes were all designed by my buddy Dave to be 0.38 deep, tapped quarter 20 holes. They were all intended to come in from this side because you can get them all from this side. Some go through, some break out, some partially break out. And that's why he knew it would trip up all this feature recognition, right? So the wizard has decided, okay, there's 5 holes. It's got them. I don't think you have to do anything now, right? It's pretty close. Well, it doesn't give any depths. So let's try just see if it did something here. Okay, so that's probably pretty close. And this one's red. Took a long time. I sure wish if you could write. Oh, okay, I should at the beginning. It split them in half because a couple are through holes and 3 of them aren't. So it divides it in 2, which SolidWorks CAM by CamWorks did. You know, all these automatic wizardy things. But it made this one red. And it turns out it's the same thing that SolidWorks CAM by CamWorks. It's trying to go in 2 different sides. It's decided that the through hole should come in from the top side, even though we're in this bottom setup. Took a long time. I wish, let's check real careful. If it says what's wrong, see, that's what you want to see. Sorry, it goes off the screen. I got a 1200 monitor. Move up, move down. Nothing tells you what's wrong. So that's a shortcoming. But it didn't take long. Let's see, what did I do? I think, oops, don't rename it. Say, edit it. And there was a place where you could switch the side. You see, oh, it's picked the drill for us, right? I mean, that is pretty wizardy if you got simple holes. 201. But see, it's a tapped hole. So really it should be doing a center drill, a drill, the way BobCAD does it. I don't even need the chamfer. Maybe it was here. Reverse Z axis. Oh, okay. It's already checked. Well, let's do that. Let's do this again. And now it's not red anymore. Okay. And now let's do our thing where we highlight the whole mess. Right. Ooh, that's not working, is it? What's going on? What's going on? Highlight both, right click, say stock simulation. I figured out the colors down here. There's a little slider and you can slide your way all the way right to the end here. And you can see it's just finishing the bottom. So that's a cool thing, right? I'm really happy. I prefer the SolidCAM simulator because it color codes when you do this compare function right here. But there are things about this one that might actually, for a real machinist, which I am not, might actually be preferable. And that's because you can hover over stuff and it has a distance here that tells you, okay, that surface is right on. What happens if we hover over here? Oh, big error, right? Because it's 2/10 up. So that might be, you know, stick with the levels of gray for the comparison as long as you can point to stuff and get an actual numeric readout to, you know, a couple microns. So what are we going to do now? I guess we're just going to go slow. Let's slow it down. Is this the speed? Speed. They don't have room. I love the user interface, that everything's concentrated down here because the big dialog boxes means you're constantly swinging the mouse and a carpal tunnel. So this concentrates, and that's why I've turned off the command manager because it just gobbles space down here. And, you know, I think that's ribbon stuff for Microsoft people. All right, so slow it down a little more. Let's say here, you got to kind of remember. So there's the drill, right? No center drill. It didn't peck them. It didn't. Did it break out? Well, it kind of, sort of. It didn't really break out here. Right? You can see the tip of the drill kind of went, but the design intent of this is they're supposed to be deep enough. And so you could tell, yeah, you can break it out. And, you know, you can change the depths. I'm sure if we go here, come on, open up and go edit. There is a depth. I also love this simplified. See, they're saying from hole top, from hole bottom. So if we say from hole top, and we've learned in all these other ones, minus 0.44, say we should see it grow a little bit. Let's see. Yes, hopefully we did. Let's go here. This isn't worthless, right? If you got basic holes, I think you'll be fine. Notice it stayed on the same tab. Boy, I gotta love this program. From hole top. Did I get that right? I hope I'm doing this right. I hate going back and seeing my mistakes in real time. 44. Oops, wrong. Minus 0.44. There we go. Say, okay, we should see those two. And are those the through holes? Yeah, see, that's why it broke it into two, because it's programmer wizardry, not programmers trying to do your thinking, not your work. So what do we do next? We collapse. We go here. We go here. We right click. We say I can't do a machine simulation. This simulation is like backplot in Master CAM. But the stock simulation is my money shot. And then here you can drag. I'm getting to love this. Drag this. You can also go here and advance. Go to the end, all the way to the end, or go one at a time, stock until next, right? But what are we doing? We are going ahead. Doesn't seem to be smart enough to do peck drilling and stuff like that, but okay, it's got a clean through hole there. I think it's got a clean through hole here as well. Yeah. So you can fix that stuff. I guess it's cool stuff, right? Judging from these scallops, we might want to go a little bit finer there. Okay, that's an old operation. Let's not backtrack. So we'll say, okay, we'll go here. And let me show you Drill Wizard, right click, delete. Are you sure? Yes. Now, you can't do it here, which really bothers me. At least I haven't seen anything that says new operation. I wish that was a little more straightforward. There's this move up, move down, which obviously, if you want to insert an operation between existing ones, I guess that's what you got to do. You got to go up here at least, or all the way to the top. Right click, new operation, drilling, and just say drill. It's got, let's see, okay, no, that's a 1/4 inch end mill. Library, it's got these drills. It's got 2 of them. I'm going to say there's a way to do this. Cut. Do you want to remove tool? See if it'll let me cut this one. Okay. So those are the tools, and I don't know why it had 2 of them. Maybe because of that upside down operation. Who knows? So what are we doing? We are in selecting a tool. And now I've learned, this is the one big dialog box, and rightfully so. I think, what are we trying to do? Centered, not metric, inch aluminum. These they all give you. They're canned. And I had all that stuff in the first episode where I showed center drill. I want a 1/4 inch center drill. Say select. So there it is, 1/4 inch center drill. The speeds and feeds, we can all fix that, right? The holes. Now this is the trick. I'm going to show it like it's going to sit in the vise. Part 0, in the second bottom setup is here on the part, so that, stock differences, you can't have it both on the stock, both part 0s on the stock. But then what I've learned, and the other cool thing about this program, it seems to obey how you pick them. Matter of fact, let me pick them in the opposite from the way I practice. 1, don't pick the side of the hole. That gives it depth information. It tries to help you. Don't help, do my work, not my thinking. So we're going to go in this direction, although usually I'd pick here where it's closer and you can watch it, a little bit closer. You're done, right? Hole top, don't say from hole bottom, do just what we did before. From hole top, go minus 0.44. Enter, and that's cool. I think it should all. Linking, drilling, wrap it out. They have a funny thing, is it chip brace? I think this is what they call peck. Although when I simulated it, it didn't want to peck. Tapping, boring, lots of good stuff, right? We're not trying to get too tedious. Bam, there it is. They might be a little deep. Let's go right here. Well, no. And notice, see, SolidWorks calls these 0.38 because it goes by, let me get closer. It goes by this corner here of the drill, right, where the flute starts, not the tip. The CAM programs all seem to want to go to the tip, and it's just doing 50 different CAM programs I've learned. Oh no, tell the CAM program to go 0.44 down. Some of the programs have center or edge. I think it might have been Visual Mill. So that's cool stuff. So that's done, right? So and let's rename, because we're good at that, center drill. Bang. And I'm pretty happy with that. Chip breaking. It tells you that it's a peck operation. That's kind of nice. Now we'll do a copy and paste. Here it is. Now this is going to be just a drill. Drill. Enter. Chip breaking. Oh, this is a mistake. Let me edit it. I forgot I was doing a center drill. See, this is, I'm starting to navigate, right? Drilling, wrap it out. Do it again. We don't have to peck drill that one, but we do want to peck drill this one. And I didn't see it doing that in the simulations. Now edit it. Okay, first thing, the tool, well, we don't want the center drill. Library. It's a little clicky, not the end of the world, right? And in general, you know, I'm going to have like 5 tools in my library. I'm going to throw away all the ones that I don't need. Maybe leave all these drills in. So now we want a number 7 drill. I happen to know, 0.201. Here it is. And that's for a cut thread. A roll thread's different. Select. How smart is it? It's smart enough to make it tool 3. You know, cool stuff, speeds and feeds. Got those edges that it inherited from when I picked them, right? That's because we did a cut and paste. And the, I had 2 mistakes. I wasn't supposed to go that deep on the center drills. I'll go back and fix that. This is the drill that goes down 0.44. Say yes. It's cool. Here, oops, no, I don't know what I just did. Here, edit. And depths. 0.2. Done. See, they shortened up just the way we want. Here we go, Control C, Control V. Now we're going to do tap 1/4-20. And this was a little clumsy. So we do edit. We go here, see the last tab. I love this program. Library. It's a little confusing because you do tools where we were, you know, inch aluminum, no taps. You got to know to go all the way down here and see taps. Then it's a little clumsy because the quarters here, they give you pitch, which no machinist I know. Oh yeah, it's a 0.05 pitch. No, it's a 1/4-20. Come on. I think if I stretch these out, yeah, finally they tell you here, the 1/4-20 should be here. I'm sure you can go in and rename all this. It's not the end of the world, right? Say select. Then what next? We got the edges because we picked that. Optimize order. Let's hope all that's right. This is where I went back, and this is why this is a keeper program. I'm not asking for my money back. Let's do 0.36, right? If you go all the way, that would mean the tap is going to where the tip of the drill is, and you would break that tap off. This is what gets clumsy about the way they talk lengths. But I guess since they've been doing it this way, the tip of the drill is the depth of the hole, you know, we're stuck, right? Live with it. So I think we're done. This is chip breaking, no. Tapping, right tapping. Dwell period 0. My machine, Avid Benchtop Pro, can't do rigid tapping. It doesn't have an encoder on the spindle. But I figured this is the use case for a lot of folks. You got a Haas, or I don't know if a Tormac can do rigid tapping. I can do single point tapping where there's a tiny little triangle and you helix it down. My buddy says he'll make like 440 threads with a single point tool. I'd like to see that. He swears. Of course, he's doing it on a Haas, not on a gantry mill. I think we're done. Okay. So tap 1/4-20. Highlight them both. This is, I wish it had stock condition like Visual Mill, like the others. But instead, you got to know to just do the whole thing, say stock simulation. Now that I've learned about the slider, where else? Okay, right about here. Does its thing. We're going fairly slow. Oh, I bombed out of it. What a moron. Okay, now where were we? Stock simulation, There's a real disconnect between the programmers and the salesmen and everybody who uses this, and machine shop owners who use the program 8 hours a day, every day of their life, that they don't understand the prototype intermittent user, which is my use case. But that's life. Okay, so it's finishing up. We should see a center drill come in. There it is. Ooh, it's real stubby. But it's only going in, and it's doing them in the order I selected them, like SolidCAM. There's the drill. It's not showing it pecking. That might just be because they're not deep enough. There's the tap. Now, the thing I loved about SolidCAM, first off, they got the color coding when you do the compare button there. And their taps, they model the little taper. Now, I went in here, made a form tool. Maybe we can even find it for you when we're done with this. But here's why the simulator is worth keeping. Even if it doesn't, you can go here and do a compare, and it kind of gets you that gray on gray. But even here, it's telling you that gray, rather than show it a gouge like SolidWorks CAM by CamWorks, many of the programs just say, well, it's a 201 hole in the solid model. That's the way SolidWorks represents a tapped hole by the tapping drill size. But it's a 1/4 inch on the outside, 0.25, the outside edge of the tap. Some companies just show that as a big red gouge because, they figure, well, technically you could think of it as a gouge compared to the solid model. But your design intent, these guys were like, well, we're going to leave it gray. So notice that it has stopped. This is the flank or the corner of the drill, the 201 drill that's gone in. And by setting that, what did I do? 0.36? I stopped short. This means that even if it was a bottoming, a plug tap, bottoming, I guess, is the bluntest tap, it wouldn't go into this cone and snap off. To me, this is worth a lot, right? So we can go here real quick. Let's go tap. Oh, what's going on? Edit. Things just seems simpler, right? All these programs, you're really doing the same thing, especially 3D. You're just sending it to ModuleWorks, right? So instead of 3.6, let's make it 3.8. Let's redo our thing. Close it up, select them both. I'm holding the control or the shift key down when I'm selecting multiple ones. I assume you know that Windows stuff. Stock simulation, use my new favorite feature. You can just scroll this way ahead of time. No, back a little. And see, and the other thing I love, the ModuleWorks simulator that both BobCAD, the cheap program, except it's not cheap when you make sure you say, I want a written quote for full 3D, everything that the demo program installs. Then it turns from 2,000 to 5,000, except even more because they want to do some maintenance thing and it's 12 grand. But the cheap program, BobCAD, and MasterCam owns the market for this stuff. Both of them use that ModuleWorks simulator. Horrible. So no, don't do what you did last time. Let's go here. And actually, we can speed this up because we know what's going on. But, 0.2. There's the 0.44, even though the hole is defined. And here, now we went a little deeper. And let's see if we can show you a little deeper, I guess right here, right? See, now it's met right at the corner. 0.38 is like the mathematics of just the tap is going in just to where the corner is. Do you want to push it that close? How tapered is the tap, right? That's why I like the SolidCam modeler. Their taps have a taper. Now, let's see if we can fiddle with that a little bit. See, you're in SolidWorks. You just go like that. You found it again. Oh, because I selected both, it's showing me both my part zeros. I love this program. All right. Wasn't happy with the installation. Oh, when they send you the email, okay, thanks for buying it. Here it is. Click on it immediately. If you wait 10 days like me, it expires. You got to start over again. When you download it, be sure, they want to just download Fusion because our Fusion brain, can't get that out of them. You got to go all products, HSMWorks. Download it. When you install it, do not install HSMWorks Premium. Do not install HSMWorks Ultra. You will spend days on help, support, chat. They don't help. You have to check Fusion Entitlement, a gibberish word entitlement combined with a different product. That's because you bought Fusion, you're entitled to use HSMWorks, right? I don't know, the way people think. And then you can get it. And I have managed to, once you get it once, it'll install in startup. Once you get it working once, I've managed to turn it off on startup so that I can have AutoCAD come up with no cam and then just enable it. And it's smart enough to go out and get licensed. So cool stuff. Let's see if we can do this. I don't know if I saved a tool. Where are we? We're at the tap. Edit. For the tool lines, let's see if we can figure out. I want to make a new tool. I don't care about the tutorials of tabs. It's not a turn tool, it's a new mill tool. See, I've forgotten where, oh, maybe it's here. Okay, so it was the second tab. And we can go down and say a form mill. I went, and you can go, there's videos, right? The trick is you got to draw half the tool and then revolve it. It's got to be a revolve. You can't build it up with cylinders like I tried the first time. Import file, we should see it. Tap form tool is just a solid part, right? Draw whatever goofy shape. So I made what looks like a tap with a taper on it. So that, I thought that was a cool thing to show you folks. There it is. You say open. Now, it does show, this, you don't see the pretty here. Okay, nobody's perfect. But it does show you. See that taper there? Flip, I think we have to flip it because this is the down, right? Otherwise it'll be drilling with that part. There was stuff I did. I made the flute length longer. That's defined here, right? You don't define that in a solid part. I guess I made it an inch. The body length, overall length, make it a little longer here. Come on. Oh, I can't change the overall length because it's defined as the shape tool. Okay, that's cool. I think the body length should come down though, right? Because you do need some stuff in the collet. I think that's it. It's going to be tool number 5. It's not the end of the world. Okay, shaft holder. Okay, we're almost out of time. And there it is, form. I gave it that name, I'm sure. Say select. It is showing in the right orientation, so I got that flip reverse business right. I think the depths, boy, all this is going to work, right? So say, do your thing. Now, look how brilliant. Right hand tapping is, but the selected tool is not a right hand. Do you want to ignore it? Yeah, it's still a tap. It's going to give me another one. Is not selected for right tapping cycle. Do you want to ignore the warning? In other words, why didn't you pick a tap tool? So it's like 2 warnings that you could be doing something seriously wrong. Not the end of the world. So I've done it. Let's go back here. We're almost out of time. I think we're just going to make it. I'm so glad I managed to this stock simulation. And now we're just going to go to end. End. Now we're going to flip to our magic spot here. And notice the gray is showing. The tip came here, and because of the angles, it just happens that tip is about 201, right? But that angle, now if you want to go through all this rigmarole, I think you'd get a feel for it with experience of like, well, this is a normal tap, with X lead in, this is a bottoming tap, this is a plug, whatever. But to me, the simulator does everything you need it to do. And real quick, let's go. It's done. Let's do our compare function. Best button ever. Essential. That's why if you buy Visual Mill, $25, expert package and above is where you get the compare function. It's not clear. They got a cheapo and a 1500. Here's a compare function. And this right down here, see, distance, 0, right? Look at this, 10 to the -5th, right? That's minuscule. These are the little scallops. And it's a numeric. So this is like the best of the both worlds. It's showing you the graphic. I wish it was color coded the way SolidWorks CAM by CamWorks, Visual Mill, and Solid Cam do. But shades of gray is okay. I've been, bumping a 0 here to make it happen, to make it suit me a little better. I don't know if you need 20 shades of gray, 1/1000th of an inch each. But being able to hover and see this distance. And then I think statistics, machining time, that's down here. And there was other places I found it. So we'll go here. Oh, we're out of time. Here. Was it stock simulation? And it's there? I guess it is. You just do it. And yeah, 33 minutes and 47 seconds. So that's how you can, by selecting and that, and then there's probably other ways to get the machining time for this thing. So let's make it pretty. For our go out screen, let's use a SolidWorks native thing. All right, that is HSMWorks, not by Autodesk, by a bunch of Danish programmers, and they're great. And Autodesk bought them, and I had a lot of trouble with Sausalito Autodesk because of the getting installed, getting that, but I'm done with them, right? Now I'm just dealing with the Danish programmers, and they did fantastic. This is a keeper. Now we're going to do shows about undercuts and chamfers and stuff like that. And then finally, after months looking at all these packages, we're going to go on that milling machine and we're going to start making some chips, doing posts, doing stuff like that. So HSMWorks, Sports DePaul here. Good luck with your CAM project. We'll catch you next time. Bye.